Okay, so yesterday we solved equations that had squares in them. You isolated the square. Even if it was a binomial square, you isolated the square, you did a plus or minus, and then you moved over. Then you got exponent after that. Today, you're going to create that situation. A process called completing the square. What you're going to do is make one of those perfect square trinomials that we've been dealing with. If you forgot, this is a perfect square trinomial. You have a binomial squared, you got first one squared, twice the product, last one squared. This right here is a perfect square trinomial, and this is what it factors into. So we're going to create perfect square trinomials so that we can factor them into something squared and then solve them like we did yesterday. Well, how do we do that? Example 6. First, you need to have an x squared, not a 2x squared, not a 3x squared, not a negative 2, x squared, not a negative x squared, plain old x squared. So here we have a plain old x squared, that's good. Second, we're going to get the x squared and x terms alone. So here I had to subtract 15. That isolated the x squared and x term. And now we're going to create a perfect square trinomial on the left. In order to create a perfect square trinomial, you need to realize that you're going to be adding something to the left because that last term is always plus. Well, what do we add to it? Well, what we add to it is the x term cut in half squared. Negative 10 cut in half is negative 5. Negative 5 squared is 25. So it's b over 2 squared. b over 2 squared. In this case, it's negative 10 over 2 squared. So we add 25. Now, I add 25 to the left. I have to add 25 to the right. Now, like we did yesterday, I can factor this perfect square trinomial on the left. Add the numbers on the right, they become 10. And then it's no different than what we did yesterday, square root, and add the 5. When you square root, don't forget your plus or minus. Add 5. There's your answer. So that's solving by completing a square when you have a plain old x squared. What if you don't have a plain old x squared? What if you've got a 3x squared? If you have a 3x squared, what you need to do is divide all terms by that 3. You want to make it an x squared, so it'll look like this, x squared plus 4x minus 1/3 equals 0. X squared plus 4x. Bring the 1/3 over to the right. Now, what do we add to both sides? b over 2 squared. What's b? b is 4. It's my new b. Whatever's in front of the x here is 4. 4 over 2 is 2. 2 squared is 4. So we add to both sides. That will allow me to factor the left into x plus 2 quantity squared. And when I add the right, I get 4 and 1/3. 1/3 plus 4 is 4 1/3. I would change that to 13/3. Now you've got some simplification to do like we had yesterday. Square root both sides. And if you square root both sides, you get x plus 2 equals plus or minus square root of 13/3. That's x plus 2 equals plus or minus the square root of 13 over the square root of 3. Can't have that, so we're going to multiply square root of 3 on top and bottom. We get x plus 2 equals plus or minus the square root of 39 on top and a 3 on the bottom. And then we subtract the 2 over. Put it in front. That's what x equals. So that's solving by completing the square. You're creating a square. So when you have a quadratic, we did factoring the first half, and factoring is nice if it works, but it doesn't always work. So what's a surefire way to solve a quadratic equation? You can complete the square every time. Generally, it's not people's favorite way, but you can do it every time. Well, how are we going to do that? By writing an equation in vertex form. So here I have a quadratic equation. It's in standard form. We wrote it in vertex form at the first half of the chapter by finding the vertex. Let's remind you how to do that. Remember how we found the vertex? We did negative b over 2a. So that would be 8 over 2 times 1. So that would be 4. Then you plug in the 4, and you plug in 4, you get 16. 4 squared is 16. 8 times 4 is 32. So you get 16 minus 32, that's negative 16, plus 7 is negative 9. So I get my vertex is 4, negative 9. This is all we did in the first half. So vertex form looks like this. If you remember that. First half we said a is whatever a is over here. A is 1, so I'll just put 1, or I don't need anything there. And it would be x minus 4 squared plus negative 9, or minus 9, either way. We plugged in our vertex. And I want to show you how to get that without doing negative b over 2a. So on our next test, you'll have to do it by completing the square. So if you do this method over here, that would be wrong. You have to show how you do it by completing the square. So how do I complete the square? I bring the 7 over to the y. Now I need to figure out what to add to both sides that will create a perfect square trinomial on the right-hand side. Well, what creates a perfect square trinomial? It's whatever this divided by 2 squared is. Negative 8 divided by 2 is negative 4. Negative 4 squared is 16. Simplify the right-hand side. Y plus 9. Factor the right-hand side. That'd be x minus 4 squared. And then isolate the y. How do you isolate the y? Minus the 9 over. And you'll notice that we got the same exact answer that we got over here by finding negative b over 2a. But we're going to be practicing completing the square, so it's like I said, on our next test, you'll need to find vertex form by completing the square. Let's do another one. This one has something in front of the x squared. That's not good. So we have to divide everything. We're going to divide everything by negative 2. So it'd be y over negative 2 equals x squared plus negative 6x, or minus 6x, plus 5 halves. Divided by negative 2, negative 5 divided by negative 2 is positive 5 halves. Okay, so this is negative y over 2. I'm going to bring over the 5 halves because I need to isolate the x squared term and the x term. So that's x squared minus 6x. Now I need to add to both sides so that I create a perfect square trinomial on the right. What am I going to add to both sides? Well, I take my b over here, which is negative 6, divided by 2, that's negative 3. And if I square negative 3, I add 9. That allows me to factor the right-hand side into x minus 3 squared. And I haven't changed the fact this is an equation because I added the same thing to both sides. Now I've got some work to do. Negative 5 halves plus 9. Well, 9 is 18 halves. 9 is 18 over 2. So this would be 13 halves. At this point, I would be tempted to kill those halves. You're going to have to do it at some point anyways. And how do I do that? I just multiply everything by 2. So if I multiply everything by 2, I'm going to get negative y plus 13 equals, I just put a 2 in front of this. Now I need to bring over the 13 and then divide by a negative. I could have multiplied everything by negative 2. That would have taken care of that negative in front of the y as well. Maybe some of you are thinking about that. That would have been a good thought. Okay, negative y equals 2, x minus 3 squared minus 13. Subtract the 13 over. But now I got to divide everything by negative 1. So I get positive y. So be careful. I'm dividing. There's only 3 terms here. There's 1, 2, 3. So this just becomes a negative 2. I don't change the x minus 3 squared at all. And plus 13. What's the vertex of that one? If I asked you for the vertex, could you tell me? Hopefully remember the vertex is 3, 13. 3, 13. Okay, last one. Let's see, divide everything by 2. Oh, this one's not nice. Y over 2 equals x squared plus 9 halves x minus 6. Let's bring the 6 over. Y over 2 plus 6 equals x squared plus 9 halves x. What do we have to add to both sides so that we create a perfect square trinomial? A half and 9 halves squared. Let's write that over here. So we got 9 halves divided by 2 squared. That's 9 halves times a half squared. So when you cut 9 halves in half, you get 9/4. Hope that makes sense. So I have a half, and I cut it in half, I get the fourths. So this would be 9/4 squared. And 9/4 squared is 81/16. Not nice. You can handle it though. That allows me to factor this into x plus 9/4 squared. It's always b over 2 at the end here. And whatever b over 2 is, that's what it factors into on the right-hand side right over here. Simplifying the left, we get y over 2 plus, well, 6 plus 81/16. 6 is what over 16? 6 times 16 is 96. So this turns into 96/16. If I add those, I get 177/16. Which at this point, I don't know, you got choices. You could kill off the fractions, or you could just bring over the 177/16. I know what's happening here, so I'm going to bring over the 177/16. And then I have to get y alone, so actually I'm going to multiply by 2. If I had killed out the fractions up here, I would have multiplied everything by 16. That would have created an extra step at the end, because I had 8y. So I just brought over the 177/16, and now I multiply everything by 2. 2 in front of the factor, and then 2 times 177/16, all that does is change the bottom into an 8. So that's the answer to that one. If I asked you for the vertex of that one, you would say the vertex is at negative 9/4, negative 177/8. That's solving by completing the square and writing vertex form by completing the square. Work together. I hope you check your odds. I hope you find you're able to get this done in my absence. Have a great day.